In the previous video, we learned about the distance formula. If you didn't watch that, I advise you do so. The link will be in the description below. At the end of the last video, I challenged you to find out how the distance formula, which we have right down here, is related to the equation of a circle. So first, let's review the definition of a circle. The definition of circle is the set of all coplanar points that are equidistant from a fixed point. Basically, what that means is you have a fixed point anywhere, and that's not part of the circle, but all points that are the same distance from it are part of the circle. So let me do my best to put a circle here. And all of these points on a circle are the same distance from the center, and that distance is called the radius. That's just a little bit of review from earlier geometry. And now let's review the distance formula. In the distance formula, you plug in 2 points, two ordered pairs, x comma y and x sub 1 comma y sub 1, and you plug them into the equation and you find the distance between them. But what if instead we knew the distance in between them and we knew one pair of points? What would that equation give us? And start thinking about circles when I give you this explanation. So let's define D. Let's say it was 3. No, not that. We don't want that circle, oval, ellipse, whatever you want to call it. Let's define D as 3. 3 squared. And then let's set it equal to something. Equal to x minus, and let's define x sub 1 as 2. Not in the white color. Let's do the same color in that color. And then let's do the other side of the equation. Plus y minus, and let's also set y sub 1 as 2. So now we know the distance between 2 points, and we know one of the points. And we're trying to find all of the x's that are 3 away from this point. And that point is 2, comma 2. So the graph of this equation would be every point that is 3 away from this fixed point. And remember the equation, the definition of a circle. And it sounds awfully similar, and that's because it is. This is the equation for a circle. Now let's try to generalize that. So instead of calling that D, let's call it R for radius. R squared is equal to, not that color again, is equal to x, nope, keep confusing the colors, x minus, and instead of calling it x sub 1, we're going to call it h. And you'll see why. Well, you might not. And we're going to close that parenthesis off, and we're going to square it. And then here we're going to have a y minus purple k. And mathematicians like to use h and k for points and centers of graphs. So what this equation is saying, that the center of the circle is h comma k. So the center is equal to h comma, k, and the radius is equal to r. Now I hope you learned something from this, and as a challenge, I challenge you to find out how this relates to the equation of an ellipse, which is basically an oval.